Three,
Three,
two,
two,
one.
one.
Let's
go!
Yes, Jassy Cooper. Thank you for joining the show. I am the host of the PBE Podcast, Troy Tittlemeyer, joined by co-host, the man, Matt the Skip Scipione, Dr. Matt the Skip Scipione. Soon, years away. We've got work to do, but working towards that. Man, what's the latest, dude? It's been probably like a half a day since we did our last podcast.
I was gonna say from the last podcast, I'd say nothing new has transpired. This afternoon, I'm gonna be getting back into it. Oh boy,
lost your camera.
Oh, lost the camera. Are we back? We're back.
We're back.
Perfect. Okay. Yeah. Not much has transpired in the last 12 hours, so nothing to report on there. But still getting after it. What's going on with you, man? Anything new for you? It's been a long 12 hours.
Yeah, dude. And when you have a 5-month-old, those 12 hours and it's that sleep change that, you're pulling from a different energy. I try to explain, like, what does that even mean? You're pulling from a different energy. You can't explain until you experience it. You're not getting sleep like you used to, and you got to still do your thing. You still got to go. So that's a different energy. But it's a good one, man. I love looking at that boy and him just growing, dude. And just, it's so fast how they're just getting it. They can't speak, but they're getting it. And anyway, it's so much fun. And I'm taking off to Texas tomorrow to hit this oil and gas lease and start doing some work out there, see if I can drastically increase the economics of the field and of this area in hopes to, make good money, make money for the area, make money for the landowners again. So it's really exciting. I'm looking forward to doing that. It's very challenging. You have a limited budget and you only have so many ideas that you can test in a couple of weeks. And so it's, pulling the trigger, doing the best you can on preparing for that and pulling the trigger and then seeing what happens. But dude, you bring up a good point, because on the backside of that trip to Texas, May 5th, man,
May 5th.
Day Mayho, Midland, Texas live PBE podcast, man. BRT Energy Advisors. We got another sponsor, Bear Claw. They're going to be selling knives at the event. We're focusing the event, and I hope you can be there, Jassy. Bring the family. You got a free invite from the PBE crew. It's going to be fantastic. It's going to be all around the idea of, we're engaging and we're networking. So we're going to have a great show. We're going to do a podcast with somebody, local legend, of course, from the Permian. And then we'll have a live band, food trucks, the free drinks, and just allow kind of, great conversation. Everyone's kind of listening, and then let's go back and mingle and then just, switch tables and move around. Yeah. It's a network event that's long overdue, and we're excited to be running this thing.
Fun.
Skips,
dude, it's going to be fun to be back live again and just see the community. I miss the community. I think that's probably the big thing, and just the familiar faces and faces that we haven't seen before, and it's this is going to be good. I'm very, very excited.
That might be worth a trip.
Yeah, it's been a very long year, so I think it's time that we all kind of get back to a little bit of that normalcy and back to what it used to be, quote unquote. So.
Yeah. Yesterday at our North Texas Geological Society meeting, we were planning for the Southwest section here in Wichita Falls in 2023, the big Southwest section event, and wondering if we're going to be able to pull that off. And someone mentioned doing virtual, and I was like, no, let's in-person events, let's get back to it.
We'll be there. We'll bring the equipment. We'll do some live podcasts. We'll catch up on your newer discoveries.
Yeah, by then.
Jassy Cooper, please allow me to try to introduce you to the audience. I mean, we explain how we cross paths and how this kind of intellectual connection that we had when I did that talk for the North Texas Geological Society. But, you're a consultant now. You've been working in the industry for at least 11 years, it sounded like?
About 7 years. I started just studying when I was 29. I'm 43 now. It took about 5-6 years to get out of school because I am a parent, and I was just kind of going to school part-time. Wow. So I've been working now about 7 years.
So in your undergraduate, you picked up Petra and you started working that software, or is that okay?
Yes, and I was hired as at that first job as in-house geologist with the option to drill my prospect, because at that point I was already making prospects. I wasn't even graduated as a bachelor's yet. I only have my bachelor's. I'm actually considering going back to school at some point. Arizona is actually one of the only schools in the United States that I found doing good geology before I ran into you, where I kind of was considering going. Otherwise, it was a couple places in Europe I can't go there.
Wow. What was the name of that first company? Because that sounds awesome. They hire you and they go, hey, if you want to drill you can drill your own prospect here.
It was Shulk Oil. They're not very, I don't even know if they're still open actually after the downturn. I ended not working there because I was making a good prospect and I found a stack of logs in the secretary's office and they were all near my prospect areas. And I was like, what are these for? And she said, the owner told me to mail them to this other geologist, older, more seasoned geologist, like giving him the data to my prospects. So I was like, I'm going to hold on to these for a little bit. So I took those logs and then went and confronted the owner of the company and said, I just wondered why you're mailing these logs from my prospect areas to this geologist. And that was on a Tuesday. And on that Friday, he let me go with about half a year's salary. That was after the downturn. So really, I was lucky to still be working, but those were my prospects, dang it. So
right.
Yeah.
Them sons of bitches.
yeah, it was a good lesson learned. Like I'm still very close to the engineer from that company, but I haven't talked to the owner of that company since. But I did, the geologist that he was mailing the logs to, I happened to run into him in Wichita Falls and a month or two later and mentioned, oh, by the way, I saw so-and-so was mailing these to you. I'm still going to work that area. And, so I'm still trying to work that area. Well, I mean, I've got it worked. I just need to polish it and sell the prospect.
Yeah. Yep. Well, it sounds good. We'll help you sell it. Let's do a commercial on PBE talking about your prospect. So what dropped out for you from this show? Just real quick, let's go around the horn. What dropped out and then we'll go from there.
What do you mean exactly?
Yeah. So like from the show, we talked about all kinds of different things. What was it from your perspective? What did you enjoy the most about this show?
Gosh, all of it. You're just getting to talk about these things with people in my local community. They're very focused on oil and gas, and they don't often want to hear new ideas. They're not, most of them aren't interested in furthering the modeling, or, they just want the location, they want to drill. So it's not often that I even get to talk to people about these ideas and, that share the same sort of excitement about it, especially. So that just all of it, to be honest.
Wow. Skippo, you got anything specific from this one?
I was going to say, I like the whole concept of the show is just that, there are these anomalies that we see. We need to address them. They're not anomalies. They're actually probably more important than what we feel is important in this complex geologic problem that we have. And I mean, talking about finding Herkimer diamonds within, the Virgilian and the Cisco and Canyon, all the way to talking about, are these really impact craters? Question mark. We touched on a lot of really good stuff today, and it's just stuff to get, the juices flowing. I'm going to say that just to kind of get that geologic curiosity sparked again. I'd say that would be a very good interpretation of this show and what dropped out for me.
Wow. That's it, man. I'm going to just reiterate what you said. And you sparked my geologic curiosity, and I have it every day. I get to work. I'm very fortunate to work with a lot of people that we do get to talk about all these anomalies in detail, and we find the publications of other data around the world that also support Herkimer diamonds and what the heck, how did they get made? So there's so much depth to what we do, and there's so much out here. There's so much we can do every day, and you've sparked my geologic curiosity, and I just can't thank you enough. I'm so honored, and I really did cherish this time together that we got to share. And listening to you talk about this, you've inspired me. You've got my juices going, like Skip said. I was so happy to be here.
I'm too excited. Sorry, I couldn't be more focused. I'm just so excited about all of it.
It was perfect. It was perfect. Jassy, thank you so much for spending time with us. Let's do it again.
Thank you so much too.
Hopefully see you in person.
Yes.
May 5th.
Yeah, I'm gonna try actually.
Right.
I'm gonna look it up, get the details. I'm gonna try to be there. I haven't looked forward to something in a long time.
Okay, then we are officially starting the conception segment of the PBE podcast with Miss Jassy Cooper. Welcome to the show, and please, we really do want to get to know you. We want to know how it developed. When was the first time you picked up a rock? Why were you inspired by these rocks? And becoming a geologist, please just enlighten us with the story of Jassy Cooper.
Okay, well, it started when I was 5. No, really, when I was in kindergarten and I learned about dinosaurs, and I guess that was probably about when the impact crater, the asteroid theory was probably coming to fruition or whatever. And right away, I'm 43. I don't know if that gives you some context. So this was the mid 80s, I guess. And right away when I heard this, red flags were going off. I mean, I remember.
You're like, wait a minute.
Yes. And so I wanted to be a paleontologist for a few years, get to grade school, junior high, I'm doing things. And I didn't think that was in the furthest part of, I never thought about that for years and years. And then when I graduated high school, I didn't have the best family life or examples. So no one really talked to me about going to college much. My grandfather did, but he passed away when I was 18, when I did first start college. What I kind of wanted to do then was be a landscape architect. So anyway, started college, then my grandfather passed away and I was kind of depressed and withdrew and ended up having a son around the age of 20. So I put, my life on the back burner for a while. I did have a great job doing completely different things than geology. I was in administrative support at a hospital and started going to school for that. Before then later, moving to Tulsa for a little while, moving back, got married, have a daughter, and at that point, got the opportunity just to go back to school and be a mom. And so I was 29 then. That was about 11 or that was probably 12 years ago. And I started studying geology just because all of my hobbies were, came in and dovetailed with geology. And I had also, obviously been interested in global cataclysm or cataclysmic events, things like that my entire life. And then
spurred on by that preschool news of bolide impact, right?
Yes. So funny. But then I guess sometime in the 90s, I did read this book called The Hobb Theory. I don't know if you've ever heard of that. It's like HAB. It stands for the, it's a fictional book, but it's based on some true scientific data but they work a story in. So anyway, that got me more interested again, in these geologic events and whatnot. And so when I did go back to school, when I was 29, I started studying geology, like I said, just because all of my hobbies and interests came back to that. Never thought I would do oil at all, but that's what I've been doing is petroleum exploration for the last 7 years or so. And it turns out I was pretty good at it. I had an opportunity while I was a student to start working with a small company here. They wanted me just to work 12 hours a week.
And this is in Tulsa?
No, this was in Wichita Falls already.
Falls. Okay.
Yes, sorry. I was attending Midwestern State here, Midwestern State University in their geologic program. Had some good professors back then. And so was very fortunate for them to, look out for the students and reach out to different companies trying to get people jobs. Well, one company expressed an interest in having someone just do might be a 3-month job, 12 hours a week, just to kind of learn Petra and try to teach it to their engineer in-house. It was a small operator, so they didn't have an in-house geologist. They wanted to get a student. So I was really lucky to get the opportunity to do that, because as it turns out, I was very good at not just learning the software, but making maps and just everything that a geologist would need to do, really, logging, reading the logs, everything just started falling into place really nicely. I never expected to be really good at that. But they ended up keeping me there for 3 years, and it turned into a thing where every prospect they got that came in, the owner would have me do my own interpretation of all of the prospects, whether it was from the most, notable geologist in the region, or, random people who sent things in. But not many students get the opportunity to just learn the software and go with it. And, I just was mapping several counties. In between doing those, my own interpretation of those prospects, I filled in holes in the database I was working and just started, before I knew it, I was mapping counties, almost on a few different horizons.
Were there any projects that really stuck out to you that you got in that you were just like, this seems like either too much, and then you just kind of got after the data, and as you were looking at the data, like things started like popping out at you? If you can talk about it, of course.
I can. There was one, a lot of them started, not just, they were all interesting in their own way. One great experience I had was, as I was there, they got this weird, it kind of fell into their lap prospect down around Beaumont, Texas, around Port Acres. It's almost getting over close to Louisiana, and they had near Spindletop almost, if you're familiar with that.
No.
Okay. Well, anyway, there are a lot of salt domes where they drill around those, and I quickly realized I do not like Gulf Coast geology, but it was very eye-opening to see how they correlated things and how they were producing around these salt domes, and also the geologists in North Texas, how they really had no grasp of how some of that geology might work. And so those were lessons in, seeing how those geologists looked at it and seeing how I looked at it. You could just tell by looking at some of these maps, it was salt domes, and they were trying to give all these different explanations and underplay the faulting in the area. And I was a little troubled by that, and quickly realized I needed some good mentorship. And so started just, reaching out to people, colleagues in the area, and lucked into getting other independent work while I was still working with that company. Back up another, while I was still working with that company, the Tannehill play. I don't know if you're familiar with the Tannehill play. Okay, that's one of the big ones that I was mapping for the few years that I ended up being at that job. And it's so interesting. And so my heart is out there in the counties that do Tannehill, but since then I've been looking deeper at, Canyon, I guess, Cisco, Pennsylvania. I don't know all the nomenclature. I know everywhere regions have their different.
As long as you don't call it the Klein, you're good.
Yeah. Okay. Yeah.
Stoney would be very mad.
I'm trying to think, Virgilian and Missouri, and
Right.
Anyway, so started working some of that more recently, and that's what I've been working those deeper sections out west since I've been consulting with Gunn. But between that job and this job at Gunn, I got the opportunity to work for a local company in Wichita Falls who, their families have, I don't know if you know much about the Wichita Falls and Archer and Clay County areas as far as exploration goes, but this used to be one of the hottest spots in the world. So there's a lot of history dating back to the early 1900s as far as drilling goes. And so the people I worked with here, they had a lot of leases in Archer County, and it's the kind of place where if you look at the geologic map, there is literally a well every 50 feet.
Whoa.
Most of the county. It's a kind of a nightmare to work, actually, because the wells are so old that you have to look at old data, sometimes even just drillers' logs. I mean,
how deep was the target that they were all going after?
A lot of them were 1,300 feet or less, but eventually they did start going to 5,000 feet, 6,000 feet, and but it was kind of a nightmare. I was spoiled to have actually worked out west before that. But it was also a great learning experience. Like all of the jobs that I've just happened to luck into have been such great learning experiences. Then I got here to Gunn and had access to a much larger database.
Wow.
Well, I say I got here to Gunn. I actually have my own company, but I'm consulting with Gunn, and my office is in their building. But had access to a much larger database for the same places that I had been working out west. And once I started really looking, correlating the whole, the whole section, when I register logs and look at an area, I don't try to just look at, one horizon. Like some geologists will, kind of focus on the one horizon or the closest ones to what they're looking at. I like to look at the whole strat column, everything I can correlate. And as I was looking at some of these features that get called reefs or whatever, I quickly realized I'm seeing inverted section, what parts of it. Eventually, what I came to see was it is a recumbent sheathfold setting, some of what we're looking at. And so from there, I just started thinking, oh my gosh, what could have caused this? And of course, it's more complex than that. There are stacked thrust fold sections of this. And at that point, I realized all of the literature I had been reading and the models I had been looking at and taught were, at least for this area, very, very wrong. Like I had been led astray. And
wow.
So I started thinking, what could possibly have done this, and I knew we're along the border near Oklahoma, where the failed rift, southern Oklahoma, Lockjaw, all of that. So I just kept thinking and finally reached out to some people in Scotland. Ian Alsop is one of the people doing really good work on sheathfold geometries and whatnot. And then I somehow got in touch with Philip Heron. I don't know if you're familiar with his work, but he is also in the UK. He was in Canada, but I think he's back in the UK now. He's done some really great work. He studied under the people who studied under Alfred Wegener or whatever.
Okay.
And then who else? J2 Wilson person. There's some of the early people in continental drift theories and otherwise, but the work has obviously come a long way since then.
Right.
So anyway, then I realized these rocks must have undergone liquefaction somehow to get to this state. And that is what, from there, that's what led me into studying more about mantle dynamics and just different processes related to that.
This is just more on the, just like lithologic question are these, recumbent folds, are they typically cherty, dolomitic, phosphatic, or are they just something totally different than that?
They have, it depends on if you get to the deeper sections, you might find some chert, but there is some dolomite. It's, I have some logs nearby I could show you, but yeah.
Has anyone cored the thing?
I haven't found core right now. What I'm looking for is dip meter. A lot of dip meter. We can't really see some of these folds in seismic the way they are. Partly, I think, because of the resolution, but also partly because the people haven't been looking at them properly, as if they are these types of folds. So that's kind of where I came in a year ago or so. And once I realized, whoa, what types of folds we are, I tried to help work with the geophysicists to, from my end, my interpretation, and to better image, figure out how to better image some of this. So that was really interesting.
What's the age of the event? When does the folding begin and end? Do you have a time idea?
Well, for the more recent folds, from the Permian on up, all we have is the nice stacked, cratonic. I don't even know the accretionary wedges, stacked. Yeah. Then,
is it like Ordovician in age, or
is
it
Ordovician? But basically between Ordovician and Permian.
Yeah.
So for
that makes sense with the timing with the Alocagen. Yeah. All right, go on. Sorry.
Oh, sorry.
My brain's spinning.
No, it's great. Another thing though, that a couple of years before I started questioning any of this geology, I was doing mud logging. I got to do mud logging on some of my own wells, or
That's
all of
awesome.
my own wells, but at the last company, I know it was really great. Also, just so lucky to have that experience. But I got to the Cisco, or I think is it Virgilian in age? I don't know. I should know that. They all run together right lately anymore. I've been so not looking at those things in a little while. I've been looking at bigger things. So anyway, got to these particular cuttings or samples, and they were around 1,200 feet measured depth, and I was looking at them under my microscope. And in this section, you may not believe me, I don't know how much mud logging you guys have done, but people always throw out the bigger chunks. Well, in this particular horizon, you can get chunks that are sometimes almost a centimeter large, and that is the sandstone that you're looking for when you get to these horizons. And it is because you get there, you see it, you smell it, and it's a familiar smell. It just really is. So I'm a big advocate of not throwing away all of the big pieces, because you need to go pick out some of the sandstone chunks. Well, I was looking at them under my microscope, and I was seeing what looked like perfect little Herkimer Diamond shaped quartz. Yes.
Did it have hydrocarbon in it? Did you see any kind
of? Yes. No, but
that's the one.
The perfect little quartz crystals, I was like, this is not just sand. There is a whole hydrothermal.
That's an injectite. That's an injectite.
Wow, I had no idea we were gonna do this, man. I was just talking about how we need to reevaluate all.
I'm up now. Oh man, this is good. Okay, keep going.
Yeah. So then I put that in the back of my mind, for a couple of years. I still have the samples. They're in my office now.
Oh my
And
gosh, those are going to be worth major dollars in the future.
really, well,
Man.
I'm really excited about them personally.
Can you explain to me exactly? Well, now that we know what's going on,
let's explain to the people what a Herkimer Diamond is first. So
Okay.
for those who don't know.
yeah, I like it. Herkimer Diamond. Let's Google it.
Yeah.
Google it. Let's see what it says. How do you spell Herkimer? Herkimer, New York. What is that? Herkimer.
Yep, there it is.
Oh, cool. I've searched it before. Okay. A Herkimer Diamond is, man, we have so many more better pictures than this, but this one will do fine. Let's get it enlarged. How do we enlarge that? It's kind of working.
I just want a Wikipedia. Okay, here we go. You want me to read it?
Oh, just a Wikipedia definition. Yeah.
So a Herkimer Diamond is a double terminated quartz crystal discovered within exposed outcrops of dolomite in and around Herkimer County, New York, and Mohawk River Valley. Not actually diamonds. The diamond, quote unquote, in their name is due to both their clarity and their natural faceting. Crystal processes double termination points at 18 total faces, these 6 on each point around the center. Because of this first discovery site was in the village. Okay, yeah, this is blah, 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 blah.
Beautiful.
Process of, yeah, okay.
Does it say it has keratin inside of it? Because that's what we're looking at here on the screen.
Yeah.
Does it talk about keratin and hydrocarbon?
Found within the inclusions are solid liquids, salt, water, or petroleum, gases, often carbon dioxide, 2 to 3 phase inclusions, and a negative uniaxial crystal. A black hydrocarbon is the most common solid inclusion.
And you can find liquid oil. We have some. We definitely have seen this. Man, I'm so excited.
These things are freaking awesome.
Yeah, they're really small. I had to look at them under the microscope, but I was like, I know that's what I'm looking at. I took it to the school to get one of my former professors to agree. Is this really what am I seeing this? They had better microscopes, and he was like, I'll be darned, yes. And so I was like, okay, this is I have some questions here. Go ahead.
Yeah.
Is this the older stuff, or what formation?
Oh, this is the newer, like in the Virgilian.
Yeah.
Lanyon.
Also,
this is up in the Cisco age.
No. You're correct. I double checked. It's Missourian Virgilian.
It is okay.
Yeah.
Okay, good. Yeah, and it's just thought to be all of these channels and whatever. Well, that made me question some things, but like I said, I had been working with very small databases at that time. And so once I started seeing this at Gunn and really thinking about mantle dynamics and that as, some of those processes is how some of this deformation must have happened, some sort of chaotic event.
Right.
I thought, well, I would imagine, some of what I'm seeing here in these tiny Herkimer Diamond, that would have been later as things are settling down. You still have geothermal, a nice geothermal setting. I haven't exactly envisioned it in my mind. I haven't gone back to that area and worked it that much.
It's authogenic mineralization. That quartz is crystallizing out at the same time the hydrocarbon and the keratin is being hydrogenated and made. It's a hydrothermally made oil process. You're looking at a translucent reactor vessel. You're holding them that you found in the chips of the drilling. Like you're in it. You found that. That's the target. That's where the oil was being made right there. I mean that. Yeah. Wow.
And so that was interesting to come back and get to think about, especially in terms of different models. Also, though, in Archer County, it's right North Texas. We're close to the Wichita Mountains. That whole situation. I'm just going to pull up my Google Earth so I don't say something wrong here.
That's the Red River right here going into Oklahoma, isn't it?
Yeah. Yes, I think that is it. Yes.
And so where are you at? You're down in North Texas.
Where Archer, I've worked right now myself, worked from Clay County all the way over to Crosby County and then north and south a few. But this particular sample was from a well in Archer County.
Oh boy, this map.
There's Clay. There's Archer.
Okay.
Yeah, Archer's just south of Wichita County, but
Yeah.
still
So we're just south of the Alocagen. So we're just south of that feature. Troy.
Geologically speaking, we're very close. Yes. And another thing about drilling wells in Archer County, when I got down to the Marble Falls, which I think they try to call, is that Lower Pennsylvania? It's right near the Barnett Shale, which is controversial sometimes in age. Mississippian. I don't know if they try to call it Mississippian or if they're still calling it Pennsylvanian. But what correlates to the Marble Falls in some counties, in Archer County, is very gassy. It looks kind of like a black shale. And I actually started wondering if it's not a sill or something. It doesn't really look like shale.
Right.
Even
chemical mud. You got to get your hands on it, and you got to just do rock eval paralysis, XRF, XRD, and it's going to scream at us that it's a chemical mud. It's not detrital. It didn't come from one of these mountains that were around this area. This is you're thinking along the lines exactly. This is some kind of hybrid igneous sedimentary process, because it's not melted rock, right? So it's not true igneous, but it's hot muds that are coming up from this mantle derived process. Serpentinization. You're looking at serpentinite muds.
Right. So I'm still on good terms with that operator from my former job. And I said, hey, next time you guys drill to that depth, I want to get some of those samples, if you don't mind.
I come out with you.
Absolutely.
I'll help catch samples.
Yeah, absolutely. They would probably be excited. They are a good little hometown operator. Their family history is in this, and they like to share and help people learn,
Oh my gosh, let's do it. PBE specific episode. Let's tell this story. That'd be amazing.
Live from the well.
Live from the well with Skippo. Hard hats back on. Let's go.
Slanging and banging.
Dude.
So just so many questions and different random opportunities along the way. And then I ended up here with this database, figuring this out. And it's like, figuring some of these things out. So that takes me back to my childhood and thinking, okay, I don't believe there was an asteroid impact that made the dinosaurs extinct, and I do believe that our Earth has experienced some very chaotic magmatic events. Yeah. And if you really look at the scale of some of it, I wonder if one of these, would it be Terra scale? I don't know if there's a larger scale, global scale event happens again. I wonder, if we're looking at it right, could we find where a safe place on the Earth might be? So I like to think deeper than just finding oil and whatnot. But maybe that's silly to even think there would be a safe place, but
that's not silly. It's silly to think that there's an asteroid out there that's going to destroy our planet, and we need to figure out a way to get off this planet. That's a silly fucking assumption. That the
conspiracy theorist in me thinks that whole get off the planet is just so taxpayers will fund a space hotel or something for the global elite to go hang out when the planet does finally explode again or something.
The global elite, let them go. That's fine.
They'll sit up there and toast each other while the rest of us fry or something. I try not to tell people that thought too often.
No, listen, it's all in fun and all in honestly in truth. I mean, we're talking about our assumptions of what we make sense of in the geologic rock record. And one of the things that is a huge controversy, but nobody really wants to talk about it, is, was it seriously an impact that made that event happen across the world? Or
Right.
was it just happened to be a timed event with a lot more other natural processes that were very chaotic, like an ultra deep hydrothermal system popping up? Serpentinization is a very toxic in place to be. You don't want to be around the Permian or around the Anadarko Basin in Ordovician time, and you don't want to be around these places. There's gases, it's bubbling up, it's toxics, it's chemical, it's killing everything. I mean, it's a crazy time, and that's a natural process that has nothing to do with an impact crater that's causing that. These are major faults happening. It's the globe doing its thing. There's a lot more to talk about than just chalking it up as, entertaining a 5th grade class with an asteroid impact. It's not.
Is this where we transition?
Is this the drill down?
I think this is where we transition.
Transitioning officially into the drill down section, Jassy Cooper. And I'm honestly going to tell you this, you are a huge inspiration, because we crossed paths when I did a talk for the Magma-Chem Research Institute for the North Texas Geological Society. I get that right?
Yes.
Making the introduction to our webinar series called the Ultra Deep Hydrothermal Webinar Series, and all these anomalies that we see in the geologic rock record as geologists that can't be explained by the traditional, source to sink, detrital ideas. There's something else going on here, a much bigger process. And you reached out and you go, man, I love these ideas. And we focused on what we're going to drill down into, which was this meteor impact crater. Could some of these craters be created in a totally different way than an asteroid smacking in? And that's all that happened. And when you said that, and you wrote a lot and you text a lot through LinkedIn, and I was truly inspired. And I remember thinking, I don't know how great that talk was, but when I saw that text and you sent me that, I go, that was it. I didn't need any other confirmation. I didn't need to think about the talk anymore. I knew there was something there because of how you reached out, and then now it's driving us to do this show. So please, let's talk about crater impact. Do you want to just go in the fundamentals of it? I have Google pulled up with some imagery of the basics. You want to look at it?
Sure.
Okay, Skippo. Here we go. Bang. Look at that. Simple. These big holes. Whoa. Now, there's all kinds of different types of holes. You can get a crater, but this has all to do with diamonds. This is a kimberlite pipe making a crater, right? So we already know, okay, there's a deep process there.
A piping feature.
Yeah.
A crater from a piping feature. That's what we would call that, right?
I mean, everywhere across the Southwest United States, right? It's like you see hundreds of craters, and they're all cinder cones that have just eroded away, right? It's a deep feature.
Yeah, or they call it a MAR, where it was an explosive event, which I guess is the same type of thing as maybe it's cinder cone, but
yeah, slightly different, because there's a MAR. I believe the one in Death Valley is a MAR, but when you are driving down the 15 or the 20, I think it's or the 30, excuse me, Amboy Crater. I know for a fact that one is a cinder cone, but okay, yeah. Anyways,
no, yeah. Oh, okay. Some of them, like those. Okay, yes, absolutely. I was thinking of El Elegante in Mexico, just kind of across the Arizona border, where they do call it a MAR. Oh, there it is.
We are looking at just massive holes in the ground, everyone, for those of you who are not watching via video. So we're just different types of craters. No, go on.
I was going to say, and then just across the border at Arizona, they call that an impact crater, when it's clearly the same type of feature as it's a MAR. And so I actually looked into how did this one, obviously in a huge igneous province or whatever, be called an impact crater. And apparently it was a corporate steel person who tried to say it must have been an impact crater. I think some geologists before that thought it was a MAR, or I don't know if that was the language they were using, but then later some steel guy, I think, I don't know who it was wanting to potentially look there for metal and other resources, but apparently some corporate steel guy came in and his influence was what decided that was an impact crater. And from there, it just stuck. It's a national landmark. Yeah.
Yeah.
Wow.
So how do you differentiate between something that's a MAR or an actual impact crater? Is it the shock quartz that, is involved with the impact, or is it something totally different?
I think with an ejecta event or something like these events, you could still have the shocked quartz. I don't think that is indication of any sort of impact. I'm not sure. I believe there are any impact craters on our planet, to be honest, or on the moon. I mean, if you go look, even in NASA's database, some of their impact craters, like, they contradict themselves. They'll call a lot of these things impact craters, but then you look at the same sort of craters, and even on, NASA website, it calls them floor fractured craters from, degassing type of craters.
Aha, that's a big one. Degas, definitely a real thing.
Yeah. Oh, yeah. And, if you're having a global chaotic event, there's no reason you wouldn't see enormous sized degassing features, on scales we're not looking at because we're not taught to look at it that way.
Two things. Yeah. We're not taught to look at it. And it's also been masked on our planet. We have an active dynamo that's constantly recycling its crust. It's very complex what we do. But when we look at Mars, or when we look at the moon, like we're looking here, our understanding of the moon was right around that 4.5 billion, two planetesimals smacked into each other. Potentially Africa is where the plume hits, because it's got the big plume that goes to the core, that big heat plume. So if that planetesimal hits there and then it broke off and it caught in our gravitational pull, because we are now the bigger body of rock, and then that rock never kept going. We had a satellite all of a sudden. Well, if you think about that and you spin both of those things and start density stratifying both of those things, and they're both filled with kerogen and water and all the gases and all the elements that we have in the universe, but they're two different sized bodies. One's Earth and one's a little guy on the moon, the satellite. The moon, to me, looks like a massive event that quickly cooled, lost all its gases, lost all its fluids, because it didn't have a gravitational pull. The Earth was way more gravity there. So it's losing and just turning into a cold, dead rock very quickly, maybe after that event, as it's trying to density stratify and become an active planet with an active dynamo, but it couldn't. It didn't have the energy. It didn't have the mass to make it happen. So I totally agree about the moon. When I look at the moon, I go, I'm not buying it. A bunch of gas escape features look like a bunch of bubbles.
Right, exactly. It almost seems elementary.
This is awesome. I could talk to you for hours about stuff like this. This is awesome. And then you got Mars. We did this big study on Mars, Gale Crater, and that this 18,000 foot tall mud mound in the middle of this big crater, this big impact looking thing. That's not an impact crater. There's no way. It's a massive mud volcano. It's been carved out with the winds on Mars, and it doesn't have chemical erosion on Mars. It doesn't have the water to run around and life masking it. So that's like a 3.5 billion year snapshot of what Mars was doing just shortly after what our planet was doing. So it's a major insight to better understand our planet. It's not understand what we think is going on and then project it out to these other bodies in the universe. It's the wrong thing. That's a wrong approach.
One comment I have on the Mars thing, in the last few years, I don't remember the details of what they called the impact or the meteor that struck this particular area of Mars, or even what was recording it. But I remember watching it, and they called it an impact event, but all you see is an explosion. You don't see anything traveling to this particular area or anything. You just see an explosion. So I wonder if there are still active, I haven't studied much about Mars, admittedly, but I just wonder, are there still active volcanic type events on Mars? Because I questioned, is that really impact, or is that ejecta.
Yeah, some kind of injectite deal coming out of it, or explosion coming out of it.
Exactly.
It appears the dynamo is definitely dead on Mars with all the data that has come back and geology studies from UNA. But yeah, I mean, who really knows?
Yeah.
Moons around Saturn that look very active, and they're talking about, they're seeing a lot of interesting things there. And I mentioned Alfredo Petrov. We did a podcast for the Magma Research Institute last night with this Mr. Alfredo Petrov. This guy, Skippo, wow, dude, his story. He ties in Rock Courier, this guy that's basically created the Tucson Gem and Mineral Show. Alfredo, just amazing guy. And he's all about MNDAT. And we kind of talked about that. And MNDAT is this great resource for all geologists, mineralogists to figure out kind of where's all this stuff been found. There's 100 known minerals on known minerals. There's only so many that are found. Most of them are microscopic. It's a very interesting conversation we had. But what I'm pulling from it was we have a planet that is so unexplored. I mean, he has a story about going somewhere where no man has ever stepped foot. And it was this crazy sequence of events that the government in Bolivia was pushing people out and kind of forcing them out there. NASA gets a hold of them because they're like, we can't even see that. It's always covered with clouds. We have no visual of what you doing over there. What's there? And he's finding all this stuff out. I mean, and then he talks about how there's countries, literally whole countries of people that do not pick up rocks. They don't report anything as far as the natural world that they live on. They do not show, hey, it's the mineral we got, it's sand, anything. They report nothing from these countries. Hundreds of countries don't report anything. We have not explored our own planet. But yet we want to explore the universe, of course, and go everywhere, light speed away. There's so much here that needs to be done. We gotta invite people and inspire people to look back and look at our feet and start picking up rocks and collecting this stuff. MNDAT's there. It's totally free. Put a rock on MNDAT and say, what is this thing? And they have specialists like Stan Keith and others that are looking at it. They go, oh, that's a pegmatite and it's got whatever. And they start explaining it and you're going, whoa. And you put it in geologic context. And all of a sudden this mountain you're looking at is, whoa, that thing, lithified at 15 clicks and it's brought up, and you're starting to put your area in geologic context. Very inspiring. It's very fun to get the community together and talk about rocks. I think so.
I think so.
Man, I enjoy this so much. I mean, you're doing it. You're an explorer. You have this ability to see and actually question and not just shelf it. I mean, man, I want those Herkimers. I don't know how or where or what kind of deal we can be done. I'll give you some serpentinite. I'll trade. Are you up for a trade?
They're tiny. You have to look at them under the microscope. They're tiny, but they're there.
I want them. Done deal.
Speaking of exploring though, and some of this during this whole revelation or whatever, I started going out to West Texas to look better at the surface of some of the areas that I wanted to possibly drill with new eyes or prospect. And one thing that I was finding was an area that's called at the surface, mapped as Pleistocene Aeolian deposits, is very clearly pyroclastic flow. Like it's very ashy. I have samples of it. I wish I could show you. They're also here, but it's very ashy. A lot of mica. It's obviously like a tuff or a tephra. I'm not sure.
Wow.
I'm not sure of the technical term for it, but it's definitely ash flow of some sort. And you can find just very small little cliffs on the side, not even cliffs, like a little bank type outcrop on the side of the road where it looks like maybe an animal dug a little cave or something. But when I got to looking at it more, there was like sulfur also shooting out. So I feel like it was a little gas vent just right there. A couple of little gas vents. They both have little sulfur.
Observation again. Wow.
So the surface out there needs to be looked at. We found just some really, really neat things there. Same at up north of the Wichita Mountains in the limestones. We found some really, really neat things there. Just things that everything ties back to this whole bigger picture being different than what I have been taught.
Wow, man, I love it. I love it. I'm so excited to keep following you and whatever publications. So let's get into the completion part of the show. I mean, we could sit literally and talk about craters in this all day long, but we won't. Well, maybe we'll do a part 2 if we really want to with Jassy Cooper, but let's get into the completion part of the show. What is it that you now are focusing on, and how are you helping our geologic community to better understand these things and to better make observations like Jassy can? And what are you doing? What are you focusing on?
I am focusing on, well, like I said, right now, I am focusing on more geomodeling this area because I think that it's going to shed insight not into just our area, but a lot of other areas. Some people are doing the great geomodeling for different areas, even parts of Texas. But in this particular region, I hope that looking at some of these things differently and diligently working to model them properly is going to help geologic exploration as far as oil and gas goes, also probably uranium or other resources. So that's a good thing. But like I said, once I started looking at it this way, I can't let go of the mantle dynamics and all of that and really wanting to look big picture. And
oh man, Mother Nature got you.
Maybe save some lives. I don't know.
What about writing papers? What about getting involved in the societies more and starting to present more specifics, like the Herkimers you found? Like, I'm down to do, like, let's do a little social about that. Well, a monthly luncheon. Just tell us everything about that.
Yeah, I do want to. Well, once I realized just how big this situation is, I would like to publish something, a publication. At this point, it's going to end up being a book, but surface to subsurface of kind of the big area, Oklahoma, almost down to San Antonio, down to near Marathon. And then, I feel like it's necessary to tie all of it in together.
Wow. So how do
it's all part of the same story, right?
I think, yes, it absolutely does. I mean, like the rocks we're looking at in the subsurface, those are similar to the rocks down at Marathon, the same types of folds, same whatever, but we're taught that it's something completely different. It's not. It's the same type of fold mountain setting. That's just subsurface. But then also we need to look, I think a lot needs to be done on how these folds came about. And that's something that I would really like to work on. Like I said, these rocks obviously underwent liquefaction, and that ties into the whole chaotic magmatic event thing. Like I could just go talk in circles, I'm sure.
Well, we got to work together. We definitely got to work together because as delegate and energy mineral counselor for the APG Southwest section, we have access to all kinds of people that are like, if you want me to go out and just take pictures of the surface, take some samples, find some lab that's willing to run XRF, XRD, rock eval on all this stuff, we could start contributing to this MNDAT on the oily side and the Herkimer Diamond side of Texas, and do this. Like, it can't be you that's going all the way down to Marathon, all the way across. I mean, it's such a huge such an area.
Yeah, we've covered.
It's a fun road trip, but a lot of unnecessary driving.
Right. I've covered a lot of it, and I enjoy road trips and doing that sort of thing, but there's no way I can see everything that I want to see and cover everything that I want to cover as one person. I've tried to recruit a couple people locally, but not much luck.
Reminds me of, real quick, it reminds me of a talk I watched in West Texas about this lady that came and gave us a big deal on archaeology. She's using satellite imagery around the world, and they're finding old grave sites or old villages, old areas where people live. And she has a community that does that. They all surf Google Earth, very detailed, right? She's got a very specific way of doing it, how to highlight and adjust your colors and, find things, how to navigate through satellite to find interesting features that need to be then actually raise the money, and the people locally can get out there and actually take more detailed stuff. But that's a fast way to just get a bunch of people in a community that just have the time and the curiosity to scan the surface. And with all these available techniques that NASA has given us, I mean, it's all free public data and access to the software. Do it, and with you driving the ship and explaining what you're looking for. How did you find these things? Maybe that's a way to do it. Maybe that's a cool way to scan a large area and then all of a sudden find 10 that need to be further explored. And AAPG and SEG have these budgets to explore, right? Well, let's use that money. This is something new. We're starting with the surface and we're going to go down to the reservoirs eventually. It's going to take years. Let's get the community alive and fired up about this.
Yeah. And make everyone pioneers.
I'm down. Skips, what do you got going in the completion, man?
Dude, I'm just kind of taking this all in. It's freaking an awesome thing to see. Cause I mean, like you said, we see the Herkimer diamonds in the Permian, right? We know they're in the Seven Rivers. I mean, Stan Keith freaking found those samples. And I mean, massive oil inclusions within that formation. And you don't think of the Seven Rivers as an oil bearing formation. And then, I mean, obviously out here in California, everything is just completely whack and doesn't make any sense to any geologic model, sedimentary model whatsoever. They're calculating TOC up into like the 50% in order to account for the oil that's being produced. It just doesn't make any sense whatsoever.
Wow.
Yeah.
I know the Herkimer Diamond stuff, dude. That is so effing cool because it's telling us that the oil was made right then, geologically instantaneous. You did not have 50 million years later and it was made. It's not that long story. It's happening right there. And that allows us to be a lot more predictable, a lot more specific about why we're doing what we do when we want to put the wellbore there, or why we want to stimulate this wellbore with this particular fluid chemistry. Like there's so much of this.
Yeah, and then tying it back into kind of what you were saying about, you have these pyroclastic flows on the surface and you're seeing these different clays and these different micas. I mean, more or less the same thing, phyllosilicates. You're finding these different phyllosilicates and it's just like, hey, wait, this can't be detrital. If this was detrital, this would already, more or less, this would be gone, right? You look at Bones reaction series and you're like, in the events at which these things occur, this should not exist in its crystal form here. But and I mean, we see it in the subsurface too. And then all of a sudden it's like, hey, why are we seeing these weird clays here that have no business being here?
High temperature stuff.
One thing that's also really interesting, just back to craters real quick, in West Texas at the surface, you see a lot of perfectly circular little holes, often get called stock ponds or sometimes playa lakes. One good example, if you guys haven't looked at this one, something to look up, Esteline, Texas.
Hold on, I'm getting there.
Okay.
Esteline.
Yeah.
How do you spell Esteline?
Esteline.
Here we go, folks.
And there is actually an interesting Texas Monthly article about this feature, but which talks about some creatures maybe now extinct. Okay, if you just go to the east there, that right there. You zoom into that. That is that's a natural feature. I don't know if they've.
Oh my gosh, it is.
Yes.
Farming.
And apparently it goes so deep, no one's ever found the bottom. People have died in there. It's some sources out who have been raised in that area say they used to swim in it, but they will not swim in it any longer because they have seen that thing swirling like a drain.
What?
Yeah, so that is some sort of piping feature that is, obviously related to how
River.
how the fluid, I don't know how, I mean, I would imagine with tides and how convection events happen. I mean, I wouldn't doubt that he saw it, maybe like a vacuum getting sucked down. I don't know, but I just think that is so fascinating. And if you start zooming out, you start seeing more and more of those features. They're not as big as that one, but they could have been other little
oh my gosh.
conduits.
What is all the rock made out of? Has anybody done detailed chemistry on the wall rock down this thing?
At the surface, it is, and this is near where I was telling you, kind of near where I was telling you the pyroclastic flow. It's a little to the southeast of here, but as far as the surface geology, I don't recall what they're calling some of this. I have a geologic map next to me.
Wow. No, it was just a random question. No worries on.
Well,
that could be the second part. That could be the second part.
Yeah. I'll get back to you on that because this is, some of this surface and these surface features. And then if you move west, of course, further west, you have all the weird little playa lakes. I don't know, but just seeing some of these things like at Esteline, that looks like like a cenote or whatever you might see in Mexico or somewhere. I don't know, but
wow. Yes.
They have it fenced off now. And I wonder if you can even drive drones or fly drones across it, because I would be willing to do that. I'd love to take a look at that place.
Absolutely. Wow. I've enjoyed talking to you more than I can express in words. No combination of words I can put together I'm so excited from what we just talked about. And we have to stay together. We have to build on these concepts. I truly believe that we have a community that would be in support of this. We have the funding that could start helping it. And with a group, with a team that we're building, like BRT Energy Advisors, helping us out, investing in us to help share this wisdom, share this knowledge, share these observations and these discoveries that you're doing. I mean, it's real life. It's happening today. We're still making so many discoveries, and there's still so much more to be made. And it has a direct impact on what we do as geoscientists. Like, we're not just dicking around all day. This is something that actually has an impact on how we think about the models and why we're spending the money we are to get these natural resources. You made that discovery in this show. I'm so excited for this show to come out.
One more thing, if we're looking at these things right, I think we could even more look at not just geologic exploration, but wildfires. I would imagine if we're looking at some of these, how the mantle or how the, processes, convective events, whatever, how it's all moving and how the plumbing is changing and whatever, I would imagine some of all of this relates directly to wildfires, the wildfires that go across Australia, Africa, California. You're right out there near fissures. Who's to say there's not something, seeping to the surface that's kind of a catalyst, or even just the reason for some of these fires rather than climate change or whatever. I mean, not that climate change isn't real, but I think it has to do with solar and mantle and other changes, not made. Mm-hmm. But so I really think that it could, just looking at all of this properly and big picture, you can just look at so much more than just geologic exploration with it, wildfires, understanding of things. I don't know.
Wow. You're spot on. I totally believe that. And it's been recorded that there's methane leaks coming out of the mountains in the Conejo Valley area around Thousand Oaks and stuff. I mean, it's there for sure. And serpentinization is just rampant right there. And so there's a lot to be discussed on that and then in details. So, I mean, I love the way you ended the show. I mean, we're talking about just not oil and gas. We're talking about all things geology, all things trying to better understand this natural world. What's impacting the climate, right? The solar is impacting the weather more so that it's our inner star that has the impact on climate. We got to integrate these ideas. We got to get there, and we're doing it. We're doing it live on these shows, and we'll keep in contact. I hope and pray that we get to keep in contact, Jassy. You're not going anywhere, right?
No, I'm not going anywhere. I just hope our industry isn't going anywhere. And that's why it's so important to look bigger picture and not let climate change shut us down. Like, we need to start talking about these processes in relation to a lot of things that we see going on in the world.
You know what's going to change them? The discoveries. It's going to change because you're going to go, hold on, I just made this discovery. And you're going, what? And then the childlike excitement that can't be hidden by our egos. They go, you made a discovery. I want to make a discovery, right? And we have that ability to do that. If climate geology is your focus and you think that it has major impact, something that you want to dedicate your life to, awesome. We have so many discoveries that need to be made on this subject. Get to work. Make some discoveries. Now, let's not argue about anything today. We're not there yet. We got the cart before the horse. Let's make more discoveries and maybe it'll make more sense. And you're doing it. You're living it. You are making discoveries as a human being today. And that is exciting. And I think that's how the conversation switches. I think that's how the narrative switches in all this. We're not against each other. You guys kidding me? What is this? This is barbaric. We're not cracking our heads together and hitting each other with baseball bats. We're trying to just do this intellectually. We are coming together. We're not barbarians anymore. Damn it. Sorry. All right, Skips, man. I think that was the completion of the show with Jassy Cooper. Do you agree?
I agree.
Awesome. All right, guys. See you. Have a good day.
All right.